All right, so in the last section, we actually took logarithmic functions and we graphed them. Today, what happens if we're given like the graph of the parent function and we're asked to write the equation of a function that's been transformed, okay? So when we look at this, it says write an equation for each of the following functions that are transformations of f of x equals log base 2 of x. So what happens is this graph has been transformed. So right away when we look at it, right, if I was to graph the parent function, I know again 2 to the 0 power is 1. So if we take 2 to the y equals x, we know we're going to get 1, 0. 2 to the first is 2, so we're going to get 2, 1. And then we know 2 to the second is equal to 4, so we know we're going to get 4, 2. Okay, so this is the parent function. So I'm going to kind of just plot these points real quick. So I get 1, 0, I get 2, 1, and then I get 4, 2. So now my goal right now is to see what happened to these points. So as I go to the graph, I'm going to look for nice points. And I see there's a nice point here, and there's a nice point here. And as I scroll, a nice point here. Well, if I look, what happened? This point went 1, 2, 3 to the left. So that went left 3. Here, 1, 2, 3, left 3, 1, 2, 3, left 3. So what happens is we're going to get f of x equals log base 2 of, what did we have to do to shift it left? Well, we took x and we're going to add 3 to the inside because adding 3 in here shifts the graph left. Okay? Second one. Again, I'm going to plot the parent function ordered pairs. 1, 0, 2, 1, 4, 2. So now I'm going to look and see where are these nice points. All right, you have one nice point here, one nice point here, and one nice point here. Now, if I look at this one, this went right to, down to. So right now I went right to, down to, here, right to, down to, right to, down to. So f of x equals, in this case, if I take these nice points, I'm going to have log base 2 of x. How do I shift it to the right? I subtract the 2. And how do I shift it down? I would subtract 2 on the outside here. Okay, so do me a favor. There's 3 U-try problems. Go ahead and try them and then come back and check your answers. So the first one here, if I go ahead and look and I graph the parent function, 3 to the y equals x, I know one ordered pair, if y is 0, x is 1. When y is 1, x is 3. And when y is 2, x is 9. So that's the parent function. So 1, 0, we have 3, 1. And then 9, 2 falls off, but I'm just going to use these 2 points. And I'm going to look on this graph to where the other nice points are. So we have a nice point here, a nice point here. And if I look, right, what happened? We went 1, 2, 3, 4 to the left. 1, 2, 3, 4 to the left. So f of x equals log base 3 of x plus 4. Because adding 4 is how we shift it to the left. B, same parent function, so I'm going to graph the ordered pairs. 1, 0, 3, 1. I could go 9, 2. And if I go along this graph, I see a nice point here, a nice point here, and a nice point here. But what happened to each of these green ordered pairs? I went up 3, up 3. Therefore, f of x equals log base 3 of x But to shift it up 3, we have to add 2 to the whole log function. And there we go. Oops, sorry, not add 2, but add 3. Sorry. And the last one. Graph the parent function 1, 0, 3, 1, 9, 2, right? And if I go and skim and I look for the nice points here, here's a nice point, here's a nice point, here's a nice point. So if I look to get to from here 1, 0 to -1, -3, I have to go left 2, down 3. So left 2, down 3. Does that work here? Left 2, down 3, left 2, down 3. So f of x equals log base 3. How do I shift it? Left 2, I add 2 inside. How do I go down 3? I subtract 3. And that would be the function of the transform function. Okay, go ahead, try the homework, and check your answers.